All right, guys, this problem asked a long question. I didn't write the whole question down, but it essentially boils down to this. We use the word molecule pretty pretty regularly, and sometimes we'll even use the word molecule to refer to individual units of both any of individual units of essentially any compound. The example given in the problem is CH4 versus magnesium bromide. The question asks, which one of these molecules, which one of these compounds does the word molecule not really work for? And what's a better term? So the word molecule doesn't really work for magnesium bromide. And the reason why is that magnesium bromide is an ionic compound. And ionic compounds are made up of positive ions and negative ions. And the reason that they stick together is through electrostatic forces. It's not about sharing of electrons like other compounds are. So the reason that the word molecule doesn't really work for ionic compounds is that they don't really exist as individual units. And so if this was magnesium bromide, then it would have two negative ions and two positive ions. And again, they're sticking together because of electrostatic forces. Now, in solution, if we're talking about in solution, the negative ions and the positive ions all sort of just float around each other, and they're all allowed to sort of just move about. And so they're all floating around. There's still a 2-to-1 ratio between the ions. But if you looked in the box that is the solution, then what you would see is you would see that the individual ions themselves don't form units. And so in that case, in the case of a solution, the word molecule isn't really working because they don't form these units. The same is actually true, or a similar situation is actually true in a solid. And while they're not actually free to move around each other in a solid, there is an array, and there isn't an individual discrete set of these ions. And now I haven't put charges on them yet because I don't think that in order for me to draw it correctly, that would become a little bit difficult. But what I'm trying to illustrate in this case is that in a solid ionic compound, there are still not individual units of ions. They're still essentially alternating arrays of negatively and positively charged ions. And if you were to look closely, there isn't an individual unit that is a magnesium bromide, in other words, an Mg and two Brs. It's just an array. And this is called a lattice structure when it comes to ionic compounds. And this is another reason why the word molecule isn't so great for ionic compounds. So what word do we use? We use the word formula unit. And so we, instead of molecule, we'll use the word formula unit interchangeably to describe an individual, to describe what would normally be referred to as a molecule. So a formula unit of magnesium bromide is one magnesium and two bromides. So there's a formula unit. We wouldn't say there's a molecule. Okay, that's it.